So I started my lecture for section 2.5. Wasn't happy with it. Um, you can kind of tell when I start a lecture and stop because you'll look at the paper I threw up on the screen. It has writing on it. Didn't feel like reprinting this, so I just left the writing. Let me just jump into the section, see if I could do a little bit better. So this is a section of word problems, and there's a lot of verbiage that we need to understand before we jump into the problems. And I just tried to type up a sheet with all the verbiage that I think that we might need to push through the problems. So most of the problems in section 2.5, the hard part of the problem is going to be, we're going to be given a sentence and we're going to need to change that sentence into symbols. Actually, we're going to change a sentence into an algebraic equation. So there's a load of key words that we're going to have to key in on in order to make that process as easy as it can be. And I started off with these four key words: square, square root, cube, and cube root. If I see the word square, I think of exponent of 2. If I see the word square root, I think of a square root symbol. If I see the word cube in a problem, I think exponent of 3. If I see the word cube root in a problem, I think of radical. So roots turn into radicals. If you have the word square and cube without the roots, they turn into exponents. Specifically, this might be something we might read in a part of a problem. If I see, as I'm reading through a problem, if I see the words square of x, immediately I see the word square. It doesn't have the word root after it, so I'm not using a root symbol. If I'm going to take those three words and make a symbol or a variable to represent them, I know the variable I'm going to use is x, and I'm going to get an exponent of 2 because square without the word root implies an exponent of 2. So square of x will translate to x squared. Similarly, if I'm reading through a problem with the goal of translating the words into symbols, if I read along and I see square root of x as 4 words are in a problem, I know the symbols I'm going to use because it says square root. The symbol I'm going to use is going to be the square root symbol, and the variable that's mentioned is going to go under the square root symbol. So square root of x is going to just turn exactly into that, x under a square root symbol. The cube of x, because it doesn't have the word root with the word cube, when I translate this into symbols, I'm going to get an exponent of 3, and the cube of x is just going to translate to x cubed. Cube root of x is going to translate to x under a cube root symbol. Once I see the word roots, I know I need to get the radical symbols if my goal is to translate the words into symbols. And the variable is always going to be given to me in these sections. The variable isn't always going to be x, but it will often be x. So that's a big deal. Those chunks of words, square, square root, cube, and cube root, they probably come in half the problems in this section. So we have to immediately, if I see square root of w, I have to know how to make that into a symbol. That's an important skill. Another important skill is going to be to rewrite the problems that are presented using really sophisticated algebra into more common words that we're used to. And I'm going to teach you how to rewrite the problems so that they're easier to understand. And in almost every time that I rewrite the problems, my rewriting is going to use the words some number, and that's a big deal in this section. That means I'm going to need a variable to represent the sum number, or a letter to represent some number. And in this section, because x comes up kind of all the time, using an x to represent some number is just going to get confusing. So we're going to use k anytime we use the word some number. For what it's worth, technically in this section, this sum number is called the constant of variation. It's somehow the number that relates the two unknowns in the problem, or the multiple variables in the problem. So these are hugely important, probably the most important words: square, square root, cube, and cube root. Some number is easy. I'm going to rewrite problems using the word sum number. I'll show you in a second. And when I use the word sum number and I want to translate that to a variable, I'm going to use k. The other key words in this problem are varies directly, is directly proportional, varies inversely, is inversely proportional, and varies jointly. So I box these things together because they have maybe keywords that are in common. Varies directly and directly proportional both have the word directly. Varies inversely and inversely proportional both have the words inversely. So these two, varies directly and is directly proportional, I consider these the same. They have the same meaning. If I'm doing a problem that has some ugly words that I need to translate into symbols, if a problem has varies directly as its keywords or is directly proportional as its keywords, I'll solve those problems exactly the same way. Similarly, if I'm asked to translate words into symbols and a problem that has the words varies inversely and a problem that have inversely proportional as the keywords, those I'll solve exactly the same way. So if I see the word inversely, regardless of how it's presented in the problem, I'm going to attack all problems that have the word inversely in them the same way. Similarly, any problem that has directly in it, I'm going to treat the same way. And for varies jointly, which is kind of the third box I made, there isn't kind of a twofer there. So let me try to go a little bit deeper into this. So if in a problem I see the word varies directly or is directly proportional, so if I see either the word varies directly or is directly proportional, immediately I think multiply. In a matter of fact, as if my goal is to translate words into symbols, if I see the word varies directly or I see the word is directly proportional in a problem, I'm going to change those words to is some number times. And let me try to show you what I mean. I wrote two examples here. The first example I wrote is y varies directly as x. So what am I going to do? I'm going to change the word varies directly as is some number times. So what I've done in my typing here, I took the sentence, or at least the part of the sentence that has the key word, y varies directly as x, and immediately in my mind, I'm rewriting it. Not that it's legible. What I'm really doing is I'm taking these entire three words and changing them to is some number times. I'm really changing varies directly as into is some number times. So my goal is to be to change words into symbols, and I usually do this in two steps. First, I change the more complicated words into less complicated words. Then I change the words into symbols. And now this, as in symbols, the letter y is going to stay a y. Is going to be an equal sign. Some number is going to be the variable or the letter k. And then times, probably plural, x is just going to be k times x. And I'd probably just write the k and the x next to each other to represent multiplication. Similarly, if I look directly underneath this, if I see the words y is directly proportional to x, I'm going to take these entire words is directly proportional to all those words. And in my mind, or physically, think of this as y is some number times x. Got lazy and didn't write the word number down. But the is directly proportional to, I can delete those words and insert these words. They'll have the same meaning. Varies directly as can be changed to those same words. And as a symbol, this is going to be y. The is equals. I'm using k for some numbers. And if I just put the x next to the k, that's going to represent multiplication. So that's the first two words. They work the same way. The next two words, varies inversely and inversely is inversely proportional. These words I'm going to loosely translate to those two, is some number divided by. And when I do these words into symbols, I'm going to form a fraction with a k in the numerator. Let me show you what I mean here. So if I gave you the words y varies inversely as x, I'm going to take these words, varies inversely as, and I'm going to change those to is some number divided by. So I could rewrite this as y is some number divided by, and then the x is going to change, stay the same. So the words varies inversely as is going to change to is some number divided by. And when I do these, the letter y is going to stay y, the is going to be an equal symbol, and then for the divided by, I'm going to form a fraction as opposed to use a division symbol. The sum number, I'm going to make a k, and I'm going to divide by x. The next level down, you might see these words. Y is inversely proportional to x. And if I see those words, I'm going to take the words is inversely proportional to and change them to y is some number divided by x. So the is inversely proportional to, I'm going to make is some number divided by. It's going to have exactly the same symbolism. It's going to still be y equals k over x. Notice I haven't snuck in any of the words like cube, cube root, square, or square root. Those will come up in a minute. The last words we need to worry about is varies jointly. And if I see something like, varies jointly translate to is some number times the product of two numbers as opposed to just one number after the k. Varies directly is multiplication, and when you translate it, you get one variable or one letter after the k. Varies inversely or inversely proportional turns into fractions with k in the numerator. Varies jointly will turn into a multiplication, but instead of having one letter after the k, you're going to get two. So is varies jointly. If I see those words, I'm going to translate to those into is some number times, and then maybe I'll get lazier than I've done here. So let me take these words right here and show you. So if I saw this, y varies jointly. I'm not digging the light right now. I don't know that this is going to help. It definitely didn't help. If I see y varies jointly as x and z, I'm going to think this is y is some number times And I think I'm going to get a little bit less wordy here and write it's some number times x and z. Very specifically, the varies jointly as, I'm going to change to is some number times. And similarly, if I want to make an equation out of this, the variable y is going to stay a y, the is going to be an equal sign, the sum number is going to be a k, and then after the k I'm going to multiply x and I'm going to multiply z. It's multiplication and there's two variables after the k. That's all the theory that we need, and now we need to kick up the notch a little bit and do some problems that also have squares and cubes in them, or squares and square roots, cubes and cube roots. So each of the first 14 problems ask me to write a variation model, and they say use k as a constant of variation. What does that mean? That just means to take the words and create a problem that has an equal sign, and to use k as the letter that you're going to introduce. For each of the problems, I took the time to type up what I've written, what I would have written, because it's going to save some time. So in problem 2, it says A varies directly as, and I changed the words varies directly as to is some number times, just like I'm supposed to. And now it's not is some number times x, it's is some number times the square root of b. So let me translate these words into symbols. First I translated the more complicated words into words that I'm more comfortable with by changing the varies directly as to is some number times. And now let me make my equation. The variable a is mentioned first, so I'm going to write it. Then the word is going to give me an equal sign. Some number is going to give me a k. Times would normally give me a times symbol, but because the times symbol is going to be implied, I'm not going to write it. And then after the times symbol, I need the square root of b, so I need a square root symbol, and the b goes under the square root symbol. That would be my answer for number 2. That's rewriting it's creating a equation to model the problem. I'll do the same for number 4. As I read through number 4, it says z varies inversely as the square of y. And what did I do? I changed the words varies inversely as to is some number divided by. Once I see the words inversely, I think divide. And I also think a fraction with k in the numerator. That's more specifically what I'm really thinking. So because I saw inversely, immediately I know I need a fraction. How do I make it a equation out of this? I'll take the variable z that's mentioned first, write a z. The is going to be in equals. Because this is inversely, I need a fraction bar before I place my k. It's a fraction with a k in the numerator, and in the denominator is the square of y. So I know I need a y in the denominator, and the symbol that's going to be with the y is an exponent of 2. And that's all there is to do for number 4. I did the same for number 6. I took the words is directly proportional to, change them to is some number times. You don't really have to do this. I just prefer to do this because it just makes it easier for me. But if you can go from the initial problem to the symbols without doing this intermediate step, more power to you. It's not necessary to do the intermediate step. I just think it makes it easier, when you're just learning how to do this. So let me make my equation. I'm going to write the variable w. The is going to give me an equal sign. Because it's directly proportional, I'm not going to get a fraction. I'm going to get a k times whatever comes after the words that give me the whatever words give me the extra symbol. And the words here that I need to worry about, what's going to be multiplied by the k is the square root of x. I'm just going to put x under a square root symbol. And that's all there is for 6. If I move on to 8, in the word 8, I see varies jointly as my key word. If I read this, b varies jointly as x and the square root of y. So I took the word varies jointly as, and I made it into this longer sentence. Is some number times the product. It's like, I don't know why I did that, but I did. If I see jointly, I think multiply. Just like if I see directly, I think multiply, but I'm going to get 2 letters after the k in jointly, 1 letter after the k indirectly. If I see inversely, I get a fraction with a k in the numerator. So to create my equation, I'm going to write the variable b. The is, I'm going to make an equal sign out of it. The sum number, I'm going to make a k. And then after the sum number, I need to have 2 variables being multiplied. The first is just going to be x. And that x doesn't have any words associated that would give me an exponent or a radical symbol. So it's just going to be a naked x. After the x, I read and the square root of y. The y needs to be under a square root symbol. So b equals k times x times the square root of y would be the perfect correct interpretation or rewrite of that sentence. So now we're getting closer to things that are have more words that are a little more complicated. So it says the monthly payment P on a mortgage varies directly as the amount borrowed. Probably, the more you borrow, the more your payment is essentially. They go in the same direction. Varies inversely, things go in opposite direction. The faster I drive, the worse my gas mileage is. Those things go in opposite directions. That's varies inversely. Varies directly, the more I eat, the more I weigh. They go in the same direction, those quantities. Anyways, I tried to rewrite this the best I could. The monthly payment, and then I didn't say on a mortgage. Eventually, you need to trim out some of the words because some of the words are just kind of almost distractors. The monthly payment varies directly, which means is some number times, and it is some number times the amount borrowed. Really, if I want to really break this down, I could say P, which is the monthly payment, is some number times B. If I just wanted to take the key, the variables that are being used, and the words that tell me how to relate those variables, that's all I really need. That P varies directly as B, which means P is some number times B. And with the B, I don't see any words like square, square root, cube, or cube root. So it's just going to be a naked B. For my equation, it's going to be P equals K times B. The is my equal sign, the sum number is the K, and the B is just a lonely old B. 12 says the demand for candy in the movie theater is inversely related to the price. If I just wanted to pull out the minimum, I could say D, which is the first variable, is inversely related if I could actually spell that, to P. That's all I really need out of this. Everything else is kind of a distractor that might help me answer a question, but these are the key words. I need the variables and the words that tell me how to relate the variables. And of course, inversely related is a fraction with a k in the numerator. So I'm going to start off, I'll think of this as D is some number divided by P. So for my equation, d is going to come first because it's the first variable that's mentioned, followed by an equal sign. Inversely is going to make me have a fraction on the right-hand side of the equal sign with a k in the numerator. And in the denominator is just going to be the price, p. I'm not going to get any exponents or radical symbols because I don't see words like square, square root, cube, or cube root. 14 will be the last part of this video, then we'll do a part 2. I hope we don't bust into a part 3, but it could happen. So let me try to push through 14. If I just want to pull out the key parts, it says the diameter d of the largest particle that could be moved by a stream, varies directly as and what is it varies directly as? The square of the velocity. I need that key word in here. This basically says the faster a stream is moving, the bigger the particles it can move. So this is kind of the key part of this. The diameter of the largest particle that can be moved by a stream varies directly as the square of the velocity, or d is some number times the square of the velocity. How about the square of v? So d is going to be the variable d, is going to be an equal sign, some number is going to be k, and I'm going to multiply k by the square of v, so the v needs to get an exponent of 2. Immediately when I see words like square, cube, square root, or cube root, I know I need to have symbols along with the variables. If I'm missing words like square, square root, cube, or cube root, I just get a lonely plain variable. So we'll call that the end of part 1, and there'll be a part 2. I don't think there'll be a part 3, but we'll find out.